Hello everyone and welcome to another short video on solving a LeetCode problem with APL. Today we will be tackling problem 1678, goal parser interpretation. Now what the problem statement says is that I'm given a string and the string consists of the alphabet, just a single letter G, open and closing parentheses, and then open parentheses, AL, close parentheses, in some order. And the objective of the problem is to take a string that consists of these three, let's call them tokens, and then interpret them into this thing right here. So G's stay as G's, an open and a close parenthesis should be replaced with the letter O, and then open parenthesis AL close parenthesis should be replaced with AL. And they give us a couple of examples as per usual. So this right here should be interpreted to goal, and this right here to goal, and this thing right here to whatever this is, algalog or something like that. Yeah, so let's see how to tackle this in APL, and let's take this example to check our solution as we go along. So let's see, my string is going to be this, my character vector in APL, and I think at least to me, the solution that I come up with first or immediately is to use regular expressions. So these are the three patterns on the left, and then I can use quad R for replace, and then I can type in what I want these to be replaced with, and then I just apply this to my string. Except this is definitely not what I wanted. What the hell did I do? Oh, right, of course, these need to be escaped because these are parentheses. Sorry about that. So, yeah. Okay, so the thing is, parentheses have a special meaning in regular expressions, so I need to tell APL or the regular expression that I want these parentheses to be interpreted literally, and that's why I'm escaping them with a backslash. So I think this is the first solution that comes to mind, and then obviously we don't need to replace G's with G's, so we can just remove this from here. And actually, in fact, we don't really need, there's something else we don't need to do. So, or there's an alternative way to tackle this, and it will segue nicely into another solution that doesn't use regular expressions, and that is, if we have this pattern, we replace it with AL. Sorry, the other way around. So if we have this pattern, we replace it with O, and then we just need to remove the remaining parentheses from the string. So we just drop them. Okay? And this is interesting because now we can write another solution that doesn't use regular expressions. It just looks for the open and close parentheses, it replaces it with an O, and then drops every remaining parens because we don't care about them. And now don't judge me too hard, but I'll show you the very long, it's not very long, but I'll show you the lengthy solution that I came up with, and then I'll show you the proper APL solution that makes better use of the primitives. And what I'm about to show you is kind of wait, what? This should be rotating the string. A not, and A to rotate. So this is not rotating the string. Why is that? Because I need to do this, of course. So might as well just write this like that. So what? Yep. Okay, so now what I'm doing is I'm taking this string and I'm putting it on top of the one rotate of the string. So I'm shifting things one character to the left, and now the idea is that I can check when the first row is equal to the open parentheses and when the second row is equal to the close parentheses, and when they are aligned, for example here. Now I wonder if I can select these two things vertically. I can't. So the open parenthesis is aligned, sorry, with the close parent, right? So this means that at this position we have an open and close parens. So what we can do is we can compare these things. So we want to check for equality, but now we want to map each of these characters, so each of these scalars, to each of the rows of this matrix. And a row here has dimension 1. That's why we are using the rank. And now all we need to do is see or find the locations where the ones are vertically aligned, so it's an AND that's applied vertically, and these are the positions of the O's. Now what we do is we use this to, let's call this a mask, a boolean mask or mask, and now we use this mask to replace the open parens with an O, with the at operator. Now the open parens were replaced with O's, and now what we can do is we can drop all remaining parentheses because we don't need them. Now I wrote this down and I was fairly happy with it, and then suddenly it struck me I was being very, very silly, because APL has this primitive that you can find right here, and it's called find, and you can give it a pattern and a string, and it doesn't need to be a string, but you can give it a character vector, 2 character vectors, and it will look for the pattern given on the left in the whole array of the right. And so this is the exact same thing we did here, but much easier to read. And so this complicated mask that we are trying to compute here, we can actually do it with find. So what we can say is that, well, can you please find the open and close parens in S? Except I did something wrong, right? I need to parenthesize things because I'm a noob. So this right here is a tacit function, and then we apply everything to S. So let me just show you. So what this tacit function does is, let's call it find parens, and that's just this, right? And now FP on S gives you that. And now the at operator can take a replacement scalar on the left and then a boolean function on the right. And now what it does is it applies the boolean function on S to determine the positions where the O should be inserted. So that's what's happening. And then finally we drop all the parentheses that we don't need with this piece right here. And we are using the without function and the commute to avoid even more parentheses. So this is equivalent to having the without right here. And so that's it. Our solution is just the dropping all of the parentheses that are left after we replace the O's in the positions where there's an opening and a closing parentheses that's consecutive. So that's it. That's our solution. Let's see. I only have simpler examples left, but we can give them a go. And so sol on this string right here gives us a goal with a lot of O's, and the simplest test case is just goal. And yeah, well, that's it. I hope you learned something, and I hope this also gives you or teaches you the lesson of always think about like the primitives that APL has to offer, right? I was thinking about this problem and I immediately came up with this solution, and as it turns out I was just being very, very silly because all of this was replaced with a single primitive, the find primitive. So yeah, take your time to get accustomed to the primitives that APL offers, and feel free to comment any questions you might have or alternative solutions you might have. And if you do comment those on YouTube, take the time to write a couple of maybe sentences explaining what it does or whatnot, because when YouTube finds a comment with too many APL glyphs and too little English text, it thinks it's, I don't know, maybe some weird kind of spam, and so it deletes them automatically. It's not even me, it's YouTube deletes the comments. So while I try to fix that issue, try to write comments that contain letters, I guess. Yeah, and other than that, I'll see you in the next video. Bye.